Hello and welcome to ECMath. This is video 3 of section 2.6. We're just going to do a bunch of problems. These are the classwork problems that we're asking you to do, and I thought I would record them live while we do them. So this video is going to be a little less formal and a little more informal, but hopefully it helps if you're stuck on any of these particular problems. So this is the list of problems that we're asking you to do. Again, try the problems before you watch this video. Do not just watch the video and think that that's a substitute for actually doing the problems. So the first group is about limit notation. Or this is not actually limit notation. This is kind of baby limit notation. We may be asking you to do real limit notation, but whatever it is, we still need to kind of talk about it. So as x approaches 1 plus, that's from the right side. That's what that little exponent, not exponent, that little superscript positive means. F of x approaches what? So this is our vertical asymptote. So f of x approaches infinity. As you approach 1 from the negative direction, that's approaching 1 from the left. This is going to be negative infinity. As x approaches negative 2 from the positive side, this is also approaching negative infinity. As x approaches negative 2 from the negative side, that's this side, that's going to be infinity. And as x approaches infinity, f of x, even though it's gone below this asymptote y equals 1, that's still the horizontal asymptote. So what's probably going to happen is this might curve up and approach. It's not going to approach anything else, especially because that horizontal asymptote is given to us. So this is going to be 1. And on the other side, we're going to approach 1 as well. So that's just the first 4. Talking about the end behavior in asymptotes using this kind of limit notation. If we were to use formal limit notation, just to maybe take this one as an example, we would write the limit as x approaches 1 from the positive direction of f of x, and that we would say that equals infinity. So that's how we turn this statement, like in 15, into limit notation. All right, let's move on to the graphing. So like we've said in class, we just want you to graph all of these. I know the book has different directions, but that's silly. We're just going to make our graphs. So for this one, nothing cancels, so there's no holes, but we do have some vertical asymptotes. So we're going to have a vertical asymptote at x equals 0 and x equals negative 4. And we're going to have our x-intercept at x equals negative 3. It's bottom heavy, so our y-intercept is going to be, horizontal asymptote is going to be at y equals 0. And so we are going to be crossing the asymptote in the middle, something like this or like this probably. And let's do a little sign chart to figure out where everything's going to be. So we need to put negative 4, negative 3, and 0 onto the sign chart. To the left, that's going to be net negative. Then we're going to have a positive. Then we'll have a positive, negative. So that's a negative. And then we should have everything positive. So altogether then, translating this sign chart, we have minus, plus, minus, plus. So the graph must look something like this. And again, you can plug in extra points if you want. If you think it helps. I don't think I need it. Oh, we have a no y-intercept because the vertical asymptote is at y equals 0. So our graph should look something like that. Let's move on to the next one. Just going to a tight spacing in between these problems so it prints out later. Okay, looks like we need to factor the bottom. So we're looking for factors of 21 that add to 4. So that looks like it's going to be an x plus 7, x minus 3. Okay, so then we have a factor that cancels. So this reduces to 1 over x minus 3, but there's going to be a hole where x equals negative 7. So to find out the location of the hole, we need to plug in the reduced version, negative 7. That's going to be negative 1/10 is the location of that hole. All right. So then this is telling us that we're going to have a vertical asymptote at x equals 3. So we're going to need kind of a lot of space for this one to fit in the hole at negative 7 and the asymptote at 3. But we can do it. Make this nice and wide. So our hole is at negative 7 and negative 1/10. So we're going to say our hole is right around there. Our vertical asymptote is going to be at 3. It's bottom heavy. So our horizontal asymptote is y equals 0. And actually, this is just a transformation of 1 over x, right? Like, oh, there it is on screen. This is just 1 over x, then shifted over 3. So the only points, I already know that it's going to contain these points. I don't feel like we need to make a sign chart because we already know what 1 over x looks like. Additionally, we have the location of that hole, so we know the graph's going to hit here. And this is just going to be really shallow, something like that. Oh, you went too far. Just clean it up. Something like that for our graph 33. Next one, 35. All right, this is the same thing, but reciprocalized. So this is going to turn into x plus 7, x minus 3 over x plus 7. Cancel those out, and we get x minus 3 over 1 with a hole at x equals negative 7. Okay, so if the hole is x equals negative 7, then the y-coordinate of the hole is negative 7 minus 3 all over 1, which is at negative 10. So we have a hole at negative 7, negative 10. And the other question is, what the heck kind of graph is this? Ooh. What the heck kind of graph is this? X minus 3 over 1. Well, we could sit around and play with the vertical asymptotes. Oh, there's none. Oh, what are the intercepts? Blah, blah, blah. Guys, this is a line. This is the line y equals x minus 3. The denominator canceled out. That happens sometimes. So it's really just going to be a line with a hole in it. Yes, indeed. So we're going to go negative 7, down 10, 2, 4, 6, 10. There's the hole. And then hopefully this comes out to an intercept of minus 3. Looks like it will. And you know what? We're just going to take our ruler, line this up. And there's our graph. So that one's a little spooky, but it is what it is. Don't overthink it. That's the lesson on this problem. All right, hopefully now we get back to some slightly more normal ones. This one's a little spicy just because of all the fractions. So nothing factors and nothing cancels, so we have no holes. So let's look for the intercepts. So when the top is 0, we need to say negative 2x plus 1 equals 0. Well, that's going to happen when 1 is equal to 2x, so x is equal to 1/2. So on our graph, which we're going to start drawing, we're going to have an x-intercept at 1/2. We need to find the vertical asymptotes. That's when the bottom is 0. So that's going to be at x equals negative 5/3, which is what? 1 2/3. So our vertical asymptote is negative 5/3. We need to think about the HAs. It's balanced. It's degree 1 over degree 1. So the HA is going to be the ratio of the leading coefficients, negative 2/3. So our HA is like right here. And we could do a y-intercept. When we plug in 0, that's going to be 1/5. So that's y-intercept. I probably could have figured that one out. I guess we should do our sign chart. So in the sign chart, we're going to put negative 5/3, positive 1/2, and then test values in between. Okay, well, when x is 0, we already found out that the function's positive. so I'm not going to bother with the sign chart. When everything is negative, like, negative 10, we're going to have a... Oh, that's kind of interesting. Yeah, plugging in the sign chart gets a little more complicated when your factors are a little spicier, but just do it. So let's, test x equals negative 10. You would get positive 21, so positive over a negative. So you would get a net negative. And then over, let's say, on the right hand, if x is 10, just testing both kind of extremes, the top would end up negative and the bottom would end up positive. So you'd still get a net negative. So the only time this thing is actually positive is right here in the middle. That's this area right here. So we're going to be above the axis and then below the axis, which must be down here because there's no other intercepts. And this one's probably going to be right in here. So altogether, the graph probably does some of this. The graph of 49 is, we're not going to get fancy. This is just a transformation of 1 over x. It's 1 over x, but it goes left 1 and down 2. That's it. So in 1 over x, the easiest thing to track is where the asymptotes intersect, right? These 3 points, basically. So we're going to take this orientation and go left 1 and down 2. And so the asymptotes will intersect right there. And the graph will hit, it's not going to hit 0, 0 anymore. It's going to come in and do this. That's how long that should take you. Don't overthink these. You got to know what 1 over x looks like and always be ready to look for transformations, because that's all it takes. Similarly, on question 53, this is a transformation of 1 over x squared. So 1 over x squared, oh, and then this is 1 over x squared, but it goes down 4. That's the minus 4. 1 over x squared looks like 1 over x, except it can never go negative. So 1 over x squared is going to look like this. If we haven't graphed that before, I think it was on the packet, but in case you missed it, it looks like this. And we're going to take that and move it down 4, so your horizontal asymptote is now going to be at y equals negative 4. Your vertical asymptote is still going to be at x equals 0. It's going to hit these 2 points. And it's going to look like this. The actual shape of the curves is a little bit steeper than those of 1 over x. Oh, that's a little bit of a sharp corner. Let's ditch that. It's a little bit steeper. Yeah, let's ditch that again. Than those of 1 over x because it goes through like 1/4, 1/4 instead of 1/2, 1/2. There, that's the ticket. But that's really not something that you're going to pick up when graphing by hand. Oh, now I want to fix the other side. Especially when you're just sketching by hand. So just make it look like nice smooth curve kind of going like that. That's your 53. Next, 57. All right, so what do we need? Well, we've got a x-intercept where at x equals 0, because that's the 0 at the top, that also is now the y-intercept. So we've got both intercepts. We've got a vertical asymptote at x equals 2. And we're going to have a horizontal asymptote at y equals 4 because it's they're both first degree factors, so it's 4 over 1. So we're going to be doing this kind of thing. This is the only point we've got. So we can already kind of guess about the shape of the graph, but let's go ahead and make our sign chart. So on the sign chart, we put 0 and 2. And we just need to test less than 0. Well, less than 0, everything's negative, negative, so this is net negative. Between 0 and 2, we have a positive over negative. So that's net. Oh, aha, screwed it up. Positive, negative, and then after 2, when x is like 10, you have everything positive, so positive. So we're doing positive, negative, positive for our graph. So let's connect the dots. Pretty clear that we have to go approach the asymptote. We have to come approach this asymptote. Over here, there's no intercepts. So we are probably going to kind of mirror what's happening on the other side. Come in on this asymptote and leave on that one. Something like that, pretty much. You know, and if you did this on a computer, it'd probably be a little more symmetric. You can always plug in a point. Like here, you could plug in, x equals 4, just to see. You know what? Let's do it. 4 times 4 over 4 minus 2 is 16 over 2, or 8. Yeah, so really here we should be hitting 4, 6, 8. So really here we should be hitting that kind of dot. And let's just clean that up to make this a little nicer. Don't have to. It's not required. But if you want to keep the nice symmetry, then you can do that, to be sure. All right, next one, 61. Come back here. All right, so again, we have numerator, denominator have the same degree. So we're going to be looking at a horizontal asymptote. Let's factor the bottom. That's a difference of squares. So what are we looking at here? Well, looks like we're looking at vertical asymptotes on x equals 1. I'm going to do a x equals 2 scale. So this is 1, 2, 3 here. This is -1 here. And we'll go 1, 2, 3. Hopefully that doesn't screw us up. Our horizontal asymptote is going to be x equals 2, y equals 2. The ratio of the coefficients. And our 0 is going to be at 0, because that's what makes the top 0. No other intercepts. So the graph, I can already guess, but the graph probably can't do this. It probably has to do this. Let's make a sign chart just to be sure, though. So we're going to put -1, 0, and 1 on the sign chart. Those are the only things we need on here. So let's see, at like 0.5. So again, I'm using the factored version when I think about the sign chart. So at 0.5, you have a positive over a positive negative, so that's negative. Up past 1, you have plus, plus, plus. To the left of like -0.5, you have negative over positive negative, so that's positive again. And then to the left of 1, we'd have, the top is still always going to be positive because it's an x squared, but the bottom would have 2 negatives, so we'd have then a net positive. So that's one of these things where like a double power on a sign chart can kind of change things out about how the signs work. Oh wait, did I do that wrong? So yeah, that's also going to be positive on the sign chart, which means that this is going to be negative here on the sign chart. I'm going to make a note that makes the top always positive, which contributes a positive to everything here on the sign chart. Okay, so how does this translate then into a graph? Well, we need to be positive to the very left, so this is this type of thing. Positive on the very far right, this is this kind of thing. And then in the middle we have to be plus, plus, minus, so we're going to be minus on both sides. So we're going to hit that 0 and then shoot on down. So we have just this little U shape, not a parabola because it has asymptotes and parabolas don't, but a U shape opening down and then these kind of branches opening up on the sides. That's a really nice one. That's a good graph to be able to make, I would say. Here's a fun observation about this one too. For 61, f of x is even because f of negative x is 2 negative x squared over negative x squared minus 1. Well, all those negatives just cancel out and you get 2x squared over x squared minus 1, which means this should have a left-right symmetry, and oh my gosh, it does. So that's just another hint you can use. You know, a lot of these graphs are not even. It's not really always worth doing the symmetry test, but sometimes it's helpful. Let's look at 65. So this one has a little negative, which we're going to have to take care of, and it has a denominator that can factor. It's bottom heavy by a lot. I'm going to write that as -1 up top so I don't miss it. So our vertical asymptotes are going to be on the 2s. We'll go back to sort of normal scaling. Our horizontal asymptote is going to be at 0 because it's bottom heavy. No x-intercepts because that's never 0. So we are going to have graphs that just completely hang out either above or below. So let's make our little sign chart and see what's going on. So we're just going to need to put -2 and 2 on the sign chart. There's a negative always on top, so I'm just going to draw that in right here. And then on the left of -2, we'll have for 3 negatives, which is negative. On the right, we'd have negative over 2 positives, so that's positive. And then in the middle, like when we plug in 0, we'd have a positive and a negative, so that'd be a positive. So this graph probably does this. Negative on that side, negative on this side, no x-intercepts, and because there's no x-intercepts, we really just, let's do the y-intercept. That's what we're missing. So when x is 0, this is -1 over 2 times -2. So that's -1 over -4, or 1/4. Okay, so we know that we need to hit 1/4, but nothing else. We can't go down. We have to stay positive. So it's going to have to do this. And there's our graph. This is another guy with even symmetry, that x squared. If you plug -x in, you'll just get x squared out. So it should have left-right symmetry. These are starting to get a little more exciting. I see some factoring. I wonder if we're going to have a hole here. So let's see. Is x plus 2 a factor? No. X plus 3 is a factor, and x minus 2 is a factor. But don't get excited and cross things out. That's not a hole. So why is it x plus 3? Because we have a positive x here, and it's -6, so we have to have plus and minus on the 3 and 2. Okay, so we have no holes. Let's start making our graph. Not you. Not you. All right, so our vertical asymptotes are going to be at -3 and +2. Our horizontal asymptote is going to be at 0 again. It's bottom heavy. There's an x squared on the bottom. But we are going to have an intercept at -2. So we have an x-intercept right here at -2. And I'm going to remember my mistake from the last problem where I didn't find the y-intercept. So we're going to plug in 0. And we get 2 over 3 times -2. So that's -1/3. So our y-intercept is -1/3. And we can use that in our sign chart also. So it never hurts to get those. All right, so sign chart. -3, -2, +2. Let's see. If all things are negative, then we have negative, negative, negative. That's a negative. Then there's no squared factors here. So as we cross everything in the sign chart, just one term's going to flip. So we'd still have, for like -2.5, you'd still have a negative, but then a positive, negative. So that's positive. When you plug in 0, you have a plus, plus, minus. And when you plug in something big, you get plus, plus, plus. So down here, up here, down here, and up here. So let's graph. So negative here. Positive here. So this just has to kind of skate by this asymptote, hit that 0, and then kind of do a little cubic thing, come over and hit that intercept we found, and then has to come and hit the next asymptote. And again, you can cross a horizontal asymptote. Horizontal asymptotes are all about end behavior, not about middle behavior. And over here on the positive side, we kind of have the mirror of what happened on the negative side. No intercepts, just hanging out in between the two asymptotes. So there we go. Graph looks like that. 79. Ooh, we have even degrees on top, so we are going to have a horizontal asymptote at 1.5. I can already tell. Let's go ahead and put that in. Everything else, I think I want to factor it, so let's do this. There's some kind of non-trivial factoring here. The bottom is really just x, and then 2x minus 5. So that's going to have x equals 0, and x equals 5 halves as its zeros. So our vertical asymptotes are going to be at 0, and 5 halves is 2.5. The top looks like maybe we need to do some grouping. So we're going to do 3 times negative 4, which is negative 12. We're looking for factors of negative 12 that add to 1. So how about 4 and negative 3? So we're going to write this as 3x squared minus 3x plus 4x minus 4. I chose that order because I felt like the 3's and 4's would go together, but it doesn't actually matter when you do factoring by grouping. But we'll group those terms together. So we can pull 3x out of here. And can we pull a 4 out of here? Yes, we can. Get 3x plus 4, x minus 1. Don't be afraid to go to the side and do some factoring by grouping. It doesn't take very long, and you should be good at it by now. And sometimes you have to. Quadratic formula here is not going to help. It's not a good use of time. And you need to factor it to check if anything cancels for holes anyway. So these are going to give us our zeros. So we're going to have a 0 at x equals 1. And x equals negative 4 over 3. I'm going to subtract 4, divide by 3. So that's over here somewhere. Okay, well, I already have kind of a sense of what this graph does. But we are going to make a sign chart just to be sure. So we need to put on the sign chart, we put the zeros, so negative 4/3. We put the asymptotes, 0. We put the other 0, 1, and the, not negative 1, but 1. And we put the final asymptote at, I'm going to call that 2.5. So we're going to have 5 little signs to check. I'm going to use the factored version here. So less than negative 4/3. All these are going to be negative. 4 negatives, so that should be positive. Maybe at like negative 1, we're going to have a positive, negative, negative, negative. Maybe at like 1/2. Positive, negative, positive, negative again. So that would become positive. Maybe at 2. We'd have a positive, 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 negative, and then over here we'd have 4 positives. So with that, so it's going to go plus, minus, plus, minus, plus, minus. So our final graph then is going to have to go plus, skate by that asymptote, minus, just hit its vertical asymptote, plus, come up from here. Oh, no y-intercept because there is a 0 on the bottom, so that gives us a non-y-intercept. And then this has to be minus. This is one of these little cute cubics in the middle again. Not actually a cubic. Cubics don't have asymptotes. It's a squiggly thing that looks sort of cubic-y. And then on the right of 2.5, we're positive, so we have some of this action again. As always, if you feel like you want to plug in a couple extra values, you're totally welcome to. I don't need to, because I've graphed enough of these and I trust my sign charts. You're totally welcome to just plug in x equals 3. Don't get too excited and spend all your time plugging in numbers, because you don't have infinite time. But if you need to plug in a couple extra numbers, you're totally welcome to. It can help on problems like this. All right, things are finally getting good. We're going to get some slant asymptote action. So on the top, we are going to need to do this division. We'll factor this out first because it factors nicely. So we get x plus 1, x minus 1 over x. So let's go ahead and put on the graph everything that we know already before we do any fancy division. So we're going to have zeros at the 1s. Let's see if I can move this down ever so slightly. There we go. We're going to have zeros at the 1s and a vertical asymptote at 0. But we know we're going to have some slant asymptote action. Oh, so no y-intercept also. We know the x-intercepts. So we need to do some long division. So let's do x into x squared plus 0x minus 1. You don't need the 0x, but it's an easy placeholder. So x times what is x squared? Oh, x times x is x squared. Subtract down, you get 0. Minus 1. X goes into minus 1 no time, so that's the remainder. And this is the equation of the slant asymptote. It's y equals x. This division's almost too simple that it feels like it came out too easily. But just again, trust that you know how to do long division and don't get too excited when things come out like that. So get out your ruler. Oh, close enough. All right. Well, with our asymptote plotted, let's go ahead and make our sign charts just to double check on everything. So we need to put -1, 0, and 1. And then we're checking into x plus 1, x minus 1 all over x. So to the left, we'll have 3 negatives, so that's a negative. Here we'll have a positive, negative, negative. Here we'll have a positive, negative, positive. And here we have 3 positives. So we're going to be, let's see if we can just graph this. We're going to be negative to the very far left. So we have to stay negative and approach our slant asymptote. Then we have to flip positive, which is going to happen. I'm going to come around this way. To flip positive, which is going to happen at our vertical asymptote. So it's going to look like this. I really want to clean that behavior up so it looks like it's approaching the asymptote, but I can't do it with my window in the way. So we're going to try one more time. 2 more times. This is just the exact wrong angle for my drawing tablet, I think is what's happening. There we go, something like this. And on the other side, we have to be negative, so this is going to come down and come up and approach the slant asymptote like that. Slant asymptotes are end behavior asymptotes, so graphs can cross them. They just have to trend towards them in the end. This one probably doesn't because it's pretty simple, but that's what it looks like when you have a slant asymptote type of situation. And for our last problem, we have another slant asymptote situation, and we know that because we have x cubed over x squared. So let's go ahead and set this up. This guy could factor. It is a difference of cubes, but I don't think we need to factor it fully. We do need to find the zeros. So this is only going to be 0 when x equals 1. That's going to be our only 0. And the bottom one does factor. It's x times x plus 2. Last time I did the division last. Let's go ahead and do the division first, just so we get everything here. So we're taking x squared plus 2x and dividing it into x cubed plus 0x squared. That's a 0 plus 0x plus 1. And let's see what happens. So x cubed into x squared goes x times, and we get x squared plus, or x cubed plus 2 x squared. We have to subtract that down, so we get minus 2x squared. Bring everything else down. And then this is going to go minus 2 times minus 2. And that's going to be then minus 4x. Subtract down, that becomes positive 4x. Bring that down, it's 1. And this is again the remainder polynomial that we do not care about when finding slant asymptotes. The slant asymptote is just the quotient y equals x minus 2. So we get our slant asymptote y equals x minus 2. We have our x intercept of x equals 1 as the only x-intercept. We have our vertical asymptotes of x equals 0 and x equals 2. And do we have a y-intercept? Oh, we do. No, we don't, because our vertical asymptote is at x equals 0. So I think that's it for our graph. Let's at least lay everything out, and then we'll make a sign chart if we need to. That didn't work. That's better. All right. So we have y equals x minus 2 at 45-degree mark. I'm going to do this just as a single solid line because it's easier. There we go. Vertical asymptotes at 0. I'll just stick with the orange. So we're just going to do the asymptotes as solid lines here. Oh. This is 0 when x is negative 1, right? So if we're solving x cubed equals plus 1 equals 0, then x cubed would need to equal negative 1. That only happens when x is itself equal to negative 1, not positive 1. So our intercept is going to be at x equals negative 1 between those two vertical asymptotes, which makes a little more sense for the eventual likely shape of this graph. Okay, now we need to make some sign chart action. Let's make it over here, shall we? So we're going to do negative 2, negative 1, 0, and that's it. Nothing else needs to go on the sign chart. All right, so to the left of negative 2, I'm just going to treat the top term as like a single term. Even though it's not factored, we're just going to treat it like it's its own thing. So a big negative cubed is negative plus 1. That stays negative. And then all of these also actually are negative. So we'd have a net negative to the left. Between negative 1 and 2, the like negative 1.5 cubed is still negative and bigger than 1. So that top stays negative. That would be negative, but this would be positive. So this is positive. Now, as soon as we flip past negative 1, this term is going to become positive again. Because like negative 1/2 to the third is not going to get balanced out by that plus 1. So we're going to have a plus, negative plus, so that's negative. And here we'll have everything positive to the right of 0. So we have negative, positive, negative, positive. So let's think about the graph. If the graph obeys all its asymptotes and does this, it couldn't be negative on that whole side, and there'd be another intercept. So this part down here with the slant asymptote, the graph, and again, plug in a point if you feel like you want to. I just don't want to. The graph's got to do something like this. And then in between the asymptotes, it's going to go positive and then into negative. Ooh, stay put, little asymptote, you silly goose. Get back to where you belong. So the graph is going to come and do this, and this. And then again, the slant asymptotes are about the end behavior, so the middle piece totally can cross those asymptotes. It's just about what happens at positive and negative infinity. And then the other side is all positive, so I know that there's like this little quadrant. That's not going to matter. This thing is just going to do something like this, where it doesn't actually cross 0. It just connects up through there. You could plug in some points, like I said, if you wanted to get a little more precise, but you don't need to, it's not required, and it's going to look something like this. All right, folks, that's it for this ECMath. I will post the solution key for you, but I thought you might just enjoy having a video of how everything here has been made. Study hard, ask your teacher for help, and I'll see you all in the next one. Bye-bye.